Welcome to ACT Notes Tutorials. My name is Dan, and I am going to give you a quick tutorial on Technology Readiness Levels. Technology Readiness Levels, TRL, are a method of estimating the technology maturity of critical technology elements of a program during the acquisition process. They are determined during a technology readiness assessment that examines program concepts, technology requirements, and demonstrated technology capabilities. The definition of technology readiness levels are a method used to measure and assess the maturity of a particular technology. The purpose of technology readiness levels is to measure the maturity of technology components for a system. The measurement allows project personnel an understanding of how much development a certain technology needs before being utilized. A TRL rating helps in measuring the progress of a project. TRL is based on a scale from 1 to 9, with 9 being the most mature technology. The use of TRLs enables consistent, uniform, discussions of technical maturity across different types of technologies. Decision authorities will consider the recommended TRLs when assessing program risk. This chart represents a graphical view of each of the 9 technology readiness levels, with Level 1 representing the lowest technical maturity and Level 9 the highest. Level 1 is basic principles observed and reported. Level 1 is described as the lowest level of technology readiness. Scientific research begins to be translated into applied research and development. Examples might include paper studies of a technology's basic properties. Level 2 is defined by technology concept and/or application formulated. Level 2 is described as where invention begins. Once basic principles are observed, practical applications can be invented. Applications are speculative and there may be no proof or detailed analysis to support the assumptions. Examples are limited to analytic studies. Level 3 is analytical and experimental critical function and/or characteristic proof of concept. Level 3 is described as when active research and development is initiated. This includes analytical studies and laboratory studies to physically validate analytical predictions of separate elements of the technology. Examples include components that are not yet integrated or representative. Level 4 is component and/or breadboard validation in laboratory environment. Level 4 is described as basic technological components that are integrated to establish that they will work together. This is relatively low fidelity compared to the eventual system. Examples include the integration of ad hoc hardware in the laboratory. Level 5 is component and/or breadboard validation in relevant environment. Level 5 is described as the fidelity of breadboard technology increases significantly. The basic technological components are integrated with reasonably realistic supporting elements so it can be tested in a simulated environment. Level 6 is system/subsystem model or prototype demonstration in a relevant environment. Level 6 is described as a representative model or prototype system, which is beyond TRL 5, that is tested in a relevant environment. This level represents a major step up in a technology's demonstrated readiness. Level 7 is system prototype demonstration in an operational environment. Level 7 is described as prototype near, or at, planned operational system. This level represents a major step up from TRL 6, requiring the demonstration of an actual system prototype in an operational environment such as an aircraft, vehicle, or space. Level 8 is the actual system completed and qualified through test and demonstration. Level 8 is described as technology that has been proven to work in its final form and under expected conditions. In almost all cases, this TRL represents the end of true system development. An example includes developmental test and evaluations of the system in its intended environment to determine if it meets design specifications. Level 9 is the actual system has been proven through successful mission operations. Level 9 is described as the actual application of the technology in its final form and under mission conditions, such as those encountered in operational test and evaluation. Examples include using the system under operational mission conditions. Thank you for watching this tutorial on the technology readiness level. Please read the webpage for more detailed information regarding technology readiness levels. Congratulations for finishing this tutorial and thanks for visiting ACT Notes.